The members of a truss have a mass of 5 kilograms per meter. Lifting is done using a cable connected to joint E and G. Determine the largest member force and specify if it is in tension or compression. Assume half the weight of each member can be applied as force acting at each joint. Looking at this structure, we know that left hand side of this truss is same as the right hand side, and we are already given member AB, member BC, and member C, which is 2 meters. And then in the center we have equilateral triangle BCF. And for knowing the properties of equilateral triangle, we know that all its members will be of the same length. Therefore, FC and BF are also 2 meters. Then we know member AG and member ED will be at the same length, and cos 30 times 2, we get our solution as 1.73 meters. To look for the length of member EC and GB, it's going to be cos 60 degrees times 2, and we get our solution as 1 meter. All we left is member FE and member GB. This can be found using the cos 30 degrees times 2 meters of the hypotenuse, and solving this we get our solution as root 3, which is 1.73 meters. Therefore AG and EF members are the same length. Now we can find the force or the weight in each member, which is simply going to be 5 kilograms per meter times gravity, and we get our solution as 98.1 Newton. We're going to do the same for AG. It's going to be 1.73 meters times 5 kilograms per meter times 9.81 meters per second square. Solving this, we get our solution as 84.96 Newton. And finally, for remember EC and GB, it's going to be 5 times 9.81. Solving this, we get as 49.05 Newton. And another thing we have to remember here, that we have been told that half the weight of each member will be applied at each joint. So let's start with joint T. So let's draw its free body diagram. So we're going to have unknown force CD and our unknown force ED at 30 degrees, and then our applied force, which is going to be half of member CD and ED. It comes up to be 91.53 Newton. Now we simply sum the forces in y direction using our equilibrium equation, and this is going to be negative 91.53 Newton, and then horizontal or vertical component of member ED. Solving for ED, we get our solution as 83.06 Newton. And this member is in tension. Now let's sum the forces in x direction. we're going to have unknown member CD in negative direction, and then horizontal component of force ED or member ED, which is 183.06 Newton times cos 30 degrees. So for CD, we get a solution as negative 158.53 Newton. This means we assumed a vector in the wrong direction. Switching it over, we get our solution in positive, and it also tells us that this member is in compression. Now we can move on to joint H, because we can't solve this until we have a reaction force from the rope. So this is simply going to be at H, we have our vertical reaction force P, our force in rope in vertical direction as P, and then we have two unknown forces, GH and HE. Both of these are at 30 degrees. To solve this, we can find our total force, which is P, because we have already found the total force or the total weight of all the members. So this is simply going to be 98.1 Newton times all our members. So it's going to be 1, 2, 3, 4, 5 members. So times 5, and then 84.97 Newton. And we have 4 members here, and then 49.05 Newton, and we have total of 2 members with this weight. And this comes up to be 92.44 Newton. Now it's super easy to get our force F, because we know that this truss is symmetrical. That means the loading is also going to be symmetrical in both GH and HG. So we can sum the forces in y direction. This is going to be our force in positive direction. So now 928.44 Newton, and then take away both of these. Force is going to be negative, and it's going to be times 2 times, I'm going to name it vertical force, and it's going to be cos 30 degrees, all equals to 0. Solving for force, vertical force, we get our solution as 536.3 Newton each. So that means our force for GH is going to be 536.03 Newton, and another 536.03 Newtons for HG. Now we can move on to joint E. At joint E, we have our force from member ED, which we have already found, and it is 183.06 Newton. Then there is unknown reaction force in member EC, and another unknown force FE. And then we have our force HE, which we just found, and it's to be 36.03 Newton. Now let's sum the forces in x direction, the y direction. But before we even do that, we need to tilt our angle so that we avoid simultaneous solution of equations. So this is going to be x, and this axis is going to be our y. Now let's sum the forces in y direction. When we sum the forces in y direction, we can have unknown force EC, and then our positive vertical component of force HE, which is going to be simply 536.03 Newton times sine 60 degrees. Correction, it'll be 30 degrees since we tilted our axis by 30 degrees. And another thing we missed is our very first thing that we pointed out, and that was half of the weight of each member will be applied at each joint that is acting. So therefore, at E, we're going to have a load downwards, and it is going to be the sum of ED and EF plus EC all divided by 2, which comes up to be 109.49 newtons. And we need the vertical component of this vector as well, and this is going to be negative 109.49 newtons times cos 30 degrees, all equals to 0. Solving for force EC, we get our solution as negative 173.19 Newton. This means we zoomed our vector in the wrong direction. Switching it over, we get our solution in positive, and this also tells us that this member is in tension. Now we can sum the forces in x direction in order to find our solution for force Fe. So this is simply going to be negative force Fe, positive 183.06 Newton, negative horizontal component of 536.03 Newton, and then positive horizontal component of 109.49 Newton, all equals to 0. Solving for Fe, we get our solution as negative 226.41 Newton. Negative means we need to correct our direction of the vector force. Switching that over, we get our solution as positive, and this also confirms that our member is in compression. Now we can move on to joint C. At joint C, we have two unknowns, BC and FC, and two knowns, EC and CD. And finally, we have our external reaction force, which is simply the sum of all the members connected to the joint and divided by half, or in other words, the average of all the members that are connected to the pin. The EC is a plus we have C plus we have BC 98.1 plus we have CD. This comes up to be 171.68. 8. To solve this, let's begin by summing the forces in y direction using our equilibrium equation. So it's going to be negative 171.68 plus vertical component of 173.9 Newton and vertical component of unknown force Fc, all equals to 0. For Fc, we get our solution as 25.05 Newton, and then it's in positive, therefore we know that this member is in tension. Now let's sum the forces in x direction. We're going to have a positive unknown force BC, negative horizontal component of force Fc, positive horizontal component of 173.19 Newton, and then negative 158.5 Newton, all equals to 0. Solving for force BC, we get our solution as 84.43 Newton. Having our solution in positive, this means our vector direction is correct, and this vector tells us that this member is in compression. And solving this last member, now we can evaluate which member has the largest force. So in this case, it's going to be force Fe and its opposite, which is force Fb. Both have 226.41 newtons, and they are in compression.